Welcome to the AI Decision Guy podcast, the show where we explore the intriguing balance between artificial intelligence and human decision making. I'm your host, Dr. Carlos Kemeny, and in each episode, we dive deep into the world of AI and its impact on various industries. Today, my guest is Justin Betteridge. After receiving a bachelor's degree in computer science with a linguistics minor from Brigham Young University, Justin went to Carnegie Mellon University, where he completed a master's degree in language technologies and pursued a doctoral degree in the same field. Before finishing, however, he left to start a company called Solvvy, which provided conversational AI solutions for customer support automation. While Justin was Chief Technology Officer at Solvvy, the company was acquired by Zoom Video Communications in May 2022. Justin is currently an AI manager at Zoom, helping to lead their efforts in large language models, text summarization, and virtual agents. All right, I am here with one of my great friends from the Carnegie Mellon days. This is, I don't know how many years ago now, probably about 10, 12 years, but this is Justin. Thanks, Justin, for being on the show. Somebody that I've looked up to for a long, long time and has been just a phenomenal friend. So Justin, thank you.
Yeah, my pleasure. Thanks for having me. It's fun.
I'm excited to have you on the show because it will be nice to have you share a little bit about the journey from the CMU days, because that's when you founded Solvvy. And so can you go a little bit through that history?
Yeah, absolutely. So I was at CMU working on a PhD in language technologies, which is kind of the merging of linguistics and computer science. So it's called natural language processing is the subfield of computer science. From a mission that I served for my church, it was like I kind of developed a love for languages, and I taught a lot of English when I was in Mongolia for 2 years. So teaching grammar, I developed a love for geeking out on grammar and things like that, and sentence structures, but of course loved computers and automation, and so that's what led me to that field and that department. That school has a really great department for language technologies called the Language Technologies Institute. So I was there for a number of years, and toward the end, I was kind of getting, not the end, but was getting more advanced in my working on my degree, and a colleague of mine proposed that we start a company together. And so we did it the wrong way, the quote unquote wrong way, which is a hammer looking for a nail. It was like, hey, we've got some experience and a little bit of knowledge in machine learning and artificial intelligence. There's got to be something we can commercialize. And so we, brainstormed for months and eventually and did a bunch of business plan competitions and eventually settled on, now looking back, a too generic direction of solving problems. We'll help people solve their problems by getting information from the web. So we basically question answering. And this was back in 2014 is when we actually left our degrees. So we left CMU before even finishing, and 2 PhD dropouts, and went to California, to Silicon Valley, to start our company because we got an investor that was interested and willing to invest in us, and we were incredibly fortunate, and that just kind of started the journey. Moved out to California, and eventually went into question answering for customer support, and kind of built up the business around that.
So this is fun because I think from a standpoint of having watched you go from that stage all the way to now, it's amazing to see the evolution of LLMs. I mean, everybody knows what that is to some degree at this point through OpenAI. But can you talk a little bit about the progression of the understanding from, the world on AI, and now how that's hit the masses, and so application wise, what that means?
Yeah, sure. And that's a great and very interesting question because I feel like our generation is kind of uniquely positioned to see this transition, honestly, because I, got my education in what now should be called machine learning 1.0 or AI 1.0, which was, now it's probably classical machine learning, where you have a bunch of training examples, and you either get labeled data somehow, and then you train a statistical or some other type of model to fit that data, and then make predictions based on that data. So that's essential the idea of machine learning, and which is what we use for natural language processing. So to accomplish any kind of language task, even like machine automatic translation, speech recognition, um, search, question answering, entity extraction. There's just so many different automated tasks associated with language that all require a purpose-built machine learning model that was trained on data specific to that task. Well, then, and that's kind of where the field was at when we started Solvvy. Actually, right when we started Solvvy, 2013, 2014, 2012 is kind of where there was the first shift. And that was the shift from classical machine learning, like I was mentioning, and the data sets for these tasks are on the order of anywhere from 100 to 2,000 training examples, right? The more, the better. But then 2012, 2014, you started to have a one area of machine learning that had always been there actually since the 60s, 1960s, 70s, is one of the earliest techniques called neural networks, artificial neural networks. And they're, ever since then, throughout the decades, there are various researchers still working on neural networks. Some at BYU, where I got my undergrad in computer science, and they were kind of the dedicated, faithful few, because a lot of the government funding, which funds most of the academic research, was not too hot or keen on neural networks. And so they kind of went through this dark, difficult period of still doing this research that they knew was promising, that they were interested in, without getting a lot of recognition and funding for it. But as computing power and data availability started to really increase in the early 2000s, and cloud computing became a thing where you could just spin up servers, and in addition, and also the advent of using GPUs, graphical processing units, for doing mathematical, matrix multiplications and mathematical operations that require a high degree of, or that can support a high degree of parallelism. You could do thousands of these computations in parallel to multiply this matrix. Because of that, artificial neural networks became much more effective and promising. And so the scale, and before that, artificial neural network, ANN, we'll just call them neural networks, they were still used. You could use there's like, I don't know, dozens of different machine learning techniques, and this was just one of the available techniques. You can train a neural network to do something like recognize digits, handwriting recognition is sort of prototypical. And so they, but as they became more and more successful, because you could have so much more compute, so much more data as well, like big data, the era of big data, we have all kinds of, just terabytes and terabytes of text available to us. These approaches became the best. They started outperforming every other approach. And these neural networks started to get bigger and bigger. So a neural network is an artificial representation of brain neurons. It's to simulate, just like our brain cells, the neurons, how they work. It's just kind of an artificial representation of that in a computer. And they started to become way more, way bigger. And so that's what they were getting deeper. These networks were getting deeper. And so that's why this new kind of advent, or this kind of, it's not really, I don't know, let's call it a resurgence of popularity in neural networks, started to become deep learning. You've heard of deep learning. It's just the same artificial neural networks, but getting deeper, much bigger and deeper. And the bigger and deeper the network is, the more complexity it can represent. Just like you can imagine, you can represent all kinds of complexity if you have more degrees of dimensions where you can represent something. And so these networks that researchers were using to accomplish these tasks, like answering questions or parsing a sentence or all kinds of different tasks, started to become more and more successful as they just added more and more data, more and more computing power. And so that happened in about 2013, 2014. Now, when I started my company, it became like heads down, let's build this product and make it work. So we kind of stuck with classical machine learning for quite a while. And we're just building product, just getting market fit. We're getting customers, keeping them happy, and doing all that. So I was just kind of like out of the research community for a while, and but kind of observing from the side how these deep learning was just becoming just taking over. I mean, really, deep learning just kind of took over every area of natural language processing. Well, one of the ways, so that was kind of the first revolution. It's called an AI revolution because really it has been. And it's so much so that it became deep learning techniques now is kind of like your first thought for most machine learning tasks. It's machine learning 2.0. That's why there's classical machine learning and now modern machine learning, which is pretty much all deep learning. Well, one of the applications of deep neural networks to text is something called a language model. And a language model just simply memorizes sequences of words and how likely different sequences of words are based on a ton of data. And so if you have access to, say, the internet as a downloaded set of text files that's like terabytes, many terabytes large, and you have the computing power to kind of crunch through that and just kind of like memorize, what words tend to come after other words, you can build up this incredible model of language that can predict the probability of a new word given some context of words. The amazing thing is that that's all it is. It's so simple, yet so powerful. It's so simple that it's literally just predicting the next most probable word given some context. But now that these deep learning models have become so big, they can represent a huge amount of context. And so as they became bigger and bigger, and they just gradually just got bigger and bigger, we started to call them large language models to distinguish them from previous, because there's been language models that have been around and used in natural language processing, NLP, for a long time. They just haven't been very big. So now they're large language models. It's a very different beast. It's trained with the deep neural network, and some people might have followed GPT-2 when that was announced. It wasn't released to the public, but it was teased to the public and got some publicity and stuff. And then GPT-3 came out, and this company, OpenAI, that's produced those, was started specifically to work on these deep learning and language models, and they just really done a great job, and then ChatGPT. So then when ChatGPT came out just a few months ago, right, just back in November, and it was so good. It's just so good at doing all kinds of things, and yet it's at the core base of it, it's literally just predicting the next most probable word. But that task has been transformed and used in so many new and different ways that now it's like it can become the brains for all kinds of higher level tasks. And that's now the second revolution. So now we're in the large language model era, and we went from classical machine learning to deep learning everything, and now large language models that are just unlocking a whole industry of new applications and jobs and possibilities that no one had really thought of before.
I've appreciated you kind of going through for the audience that progression because you've been through those cycles. I think that you mentioned a word that I love in the decision making framework, which is complexity. You have these AI models that are phenomenal in great complexity where we struggle when we have opportunity cost. Our brains naturally go through those top options, right? And we then select. But when we have too many options as a human, we kind of lock up, right? And we don't even make decisions in those moments. Whereas the model doesn't see that. The model has a great ease to score things, and maybe it gets it wrong sometimes, but it does simplify quite a bit in milliseconds instead of what might take people weeks to think about, and then they lose sleep over, right?
Yeah.
How do you think about this? The AI model puts out something and it's easy, and maybe it's not perfect, but and maybe in many situations it can be very good. But the simplification of decision making for people, how do you think about this across use cases? Certainly it's situational, but how should an innovator, for example, think about uh, applying AI to simplify decision making use case by use case?
That's a great question, and very interesting to think about. And I think the core thing to keep in mind is that there's no magic here. Like, where does this intelligence come from? It just comes from text on the internet. And this thing is so good at memorizing text from the internet and lots of other places. And by the way, to be clear, they memorize a bunch of text from the internet, but then they put it through this training phase where they tell it, hey, if I ask you to do this and you respond this way, that's good. Do it like that. Respond in a nice conversational manner. Or if I ask you to do something that's nefarious, uh, don't do it. So that it goes through this training phase called fine tuning or instruction tuning, where it is learned. You teach it to kind of follow instructions. Now, by teaching it, you're just updating its numbers, its probabilities, as to say, well, when the input is like uh, this type of word should be more probable than this type of word. I mean, that literally is what it is. That is the intelligence. It's just a huge amount of numbers. So we really shouldn't think that it has some real intelligence. We shouldn't trust in it like it knows everything with perfect fidelity and accuracy. And it's a wonderful tool, but it really literally is just predicting the next word probabilistically given a whole bunch of previous words. And so it just does that really fast and really powerfully with a whole bunch of context before. So it's able to say, well, if I have this document, this document, this document, and then you ask me this question, well, gosh, the most probable answer based on all these previous context tokens is this word, then this word, then this word, then this word. And so it's able to, it's able to answer questions. It's able to do a lot of things. But if you really play with them enough, you'll notice that it can say something that's just flat out false or silly or funny, or if you game the system correctly, you can get it to say things that are offensive in a lot of ways. So, there's websites that will where people share, hey, I was able to game the system this way and jailbreak the model to do what I want it to do, which is kind of not very ethical or safe. But it's able to do that just because it's just a tool. It's just like a really fancy hammer. It's not really a brain. It's not really an intelligence, even though it acts very intelligent. In the same way that a self-driving car can act very intelligent, but you're not going to trust your self-driving car to make investment decisions for you. I mean, it just because it exhibits intelligence doesn't mean it is a true intelligence and is capable of reasoning like we are. It's really only capable of reasoning in the way that some text on the internet has reasoned. And so it's yeah, I'd leave it at that. It's really it exhibits a lot of intelligent aspects, and it's really useful. It's incredible. And I'm honestly amazed, even knowing all the details of how it's built. I'm amazed at what it's able to do. That I'm amazed that it's simply just probable. The next most probable word is able to reason to such an extent, and it's impressive. It's amazing, but there is a limit. We shouldn't go too far and think that this is going to give me every answer in a completely accurate way. We have to keep guardrails, and that's going to be the challenge of the next 10 years.
So I agree. I think that, you talk about this as a challenge, right? The challenge, it's delineating. I think if I can articulate what you said, it's delineating what we should lean upon it for and what we shouldn't. And this actually is a very critical skill for the next generation, including our generations, right? Where we have AI that we will depend on. And I think that in some ways we look at OpenAI and it's changed the nature of work. For example, summarization of SEO tasks, or to write an email for a sales interaction. This is now embedded in those that are effective in doing work. And so that paradigm has sailed. It's the point of no return. We talk about point of no return often, but that is a very technological advancement, useful term, where we just don't go back to the way that it was before. The problem with decision making in many ways, I think, is this dependency, the risk of dependency, which we're seeing already applied to task automation. But I'm actually more concerned about decision automation and outsourcing of decision making. So I'll use an example, and then I'd love for you to comment. But let's say that we automate the car. So now teenagers don't drive anymore, and they don't have any decision making skill that they're building. And that's a lot of complex decision making skill that you're giving a teenager. Now, not every teenager needs to drive to be able to gain great decision making skill. We have lots of examples in the world where this isn't the case. But for the average teenager, is it helpful or not? And how do you replace that? If you take a lot of these mini decisions, these skill building decision making for, let's say, a teenager who's developing their brain, how enabled or disabled are they in being able to make bigger decisions? And I think Kissinger and Schmidt, they just wrote an opinion piece a couple months ago in WSJ that I've advocated everyone read. And the reason why is because it talks about a rewiring of the brain, that this delineation that you've alluded to here of what is something that could be useful for versus something that's not actually could even be even micro. We can build a micro case for this, which is even verifying information sentence by sentence that's being output by AI to ensure that what we're getting is truth. And so if you could comment about this, how does a person, how does a team, how does an organization, how does a society start gaining this validation and this observability skill towards these models that are outputting at bulk every second recommendations, decision making, automation, all of that? How do we operate? How do we go forward now?
Yeah, great question. Just a couple of things. When you first talked about the self-driving car, and as we use those more, and will teenagers miss out on those opportunities to learn how to make decisions? What went through my mind was the movie Wall-E, because I see a lot of animated movies. I've got kids, and I remember that one. And it's just so funny. The humans, they launched themselves into space because Earth had become uninhabitable, and over time they had this intelligent ship that did everything for them, and they ended up just riding around on little pods, slurping their smoothie that had all their nutrition. And after, for years of doing that, their bones started to separate. They became really weak, so they couldn't even walk around. And it was just it's funny how that's making a statement. If you automate too much, it's going to have an effect on you. Like you can't get away from the effect that automation is having on those that are doing, making use of it. And of course, historians will talk to us for hours about how technology has changed our lives and affected humans, and that's part of the advancement of civilization. But we should go into it open-eyed. We shouldn't just blindly try to automate everything we possibly can and not even think about the ramifications. Because it's a good point. I mean, like, what do you learn when you're in high school writing an essay? Writing your first essays in your English class. How much do you learn about formulating words? Like taking a thought and figuring out the right way to say that. I mean, how many times have we grappled with that? And it's an art form. Some people love to do this, to like formulate words and create language, and that is their craft, right? I love words. I love language. I love articulating things. That's it's not, I wouldn't call that my craft, but it's something that I enjoy doing. And now I'm just going to let a computer do that for me. I think there's going to be certainly some, there's been computer generated music for a while, but is it mainstream? Not really. Now we have computer generated art, AI generated art, visual art. We're going to have computer generated text, obviously, everywhere. But I think we're just going to have to learn to use it like any other new technology. Okay. It's useful here. It's automating this mundane task that makes my life better. So I think it's really that comes down to, is this making your life better? And maybe by making your life better, it's making someone else's life worse. So we have to think about that. Are we displacing jobs? And if we're doing that, we need to find better ways to employ or educate people so that all boats rise with the tide. But I don't know. That's an excellent question. We can't get away from. I mean, in my opinion, this is just my opinion, is that we should make sure we keep training ourselves and future generations to do these things, like formulate words and language and speak and communicate effectively, and make sure we keep those training processes in place and not let them shortcut or get around those exercises that we know will build those skills that are important for a healthy and productive life.
Yeah, and I think that the application for a technologist, I mean, you've led technology now for many years, but in technology we have a sandbox and move it to dev and move it to prod, right? In data pipelines, similar, there's auditing, there's observability, there's exception-based reporting when something goes wrong, right? So we have monitoring. Should the same happen for decision making? And the data that you're talking about with these LLMs, maybe let's talk about that for a couple minutes here. How do we observe and how do we create effective feedback loops to make, and I think the key word here is deliberate decisions around how we live and coexist with AI? And I think the difference from every technology before to now is a lot of technology that has advanced us is actually more around automation. Mm-hmm. That automation piece of making work easier has been the name of the game for most things up until this point in time. AI is different because decision-making is the focal point. The automation of the decision is how humans progress. That is the currency by which we grow. We purchase with our own decisions and the accountability of our decisions, our growth. And so if you remove that with now the automation or outsourcing of decision making, you cannot grow. That is a pretty bold statement. That's my statement, but I believe that firmly. I have conviction around that. And so the question then is, if we now coexist with AI to grow, and we need to make deliberate decisions to not let everything be outsourced so that we can continue to have human progression, then how do we create observability that signals a red flag when maybe the data is off. Maybe, we've been trusting it 99% of the time or 100% of the time, but there's this one statement, misinformation. Or maybe and we talk about maybe corrupting the data. We'll talk about nefarious purposes. If I want to corrupt a large language model, maybe it's not throwing up a website with a bunch of garbage. Maybe it's just infiltrating a lot of mainstream data with inaccurate statements over and over and again, right? And so now there's this challenge that society has to flag. And that's a very challenging situation, which we've seen over the last few years play out. So, how do we do this? How do we move into this world technologically in which we create effective monitoring, effective observability, and that this is, I hate the word democratized because it's overused and obviously misapplied many times, but in many ways, this is a democratized requirement for coexisting with AI. Would you agree with that statement?
Yeah, for sure. And one thing I wanted to mention, I think the key with how do you monitor, how do you alert, how do you keep those guardrails, and it's already starting to happen, is you use this technology against itself. So you can train a separate model to look at the output of another language model and ask, hey, is this accurate? Based on, because again, it was just probabilistically generated, just statistics, just saying, look, whatever's most probable, there it is. Well, you roll a dice, you flip a coin, you're going to get different results each time. That's probability. And so you could say, hey, regenerate that. I don't know if I like that. Okay, here's another one. And you can have a separate model that is kind of a good cop, bad cop. It's the one kind of looking and saying, no, that's not quite right. Let's try this again, or let's dig into this further. Okay, you generated this paragraph. I don't like this one sentence. Generate me another sentence, and this is what people are starting to do all the time now is kind of have another language model review the output of one language model and revise it, right? So asking for revisions. But I think if you ask me to kind of step out on a limb and make a prediction, I think that going forward we're gonna see a lot more predictive assistance from AI in predicting the future, right? We have weather forecasting, right? These weather forecast models, I don't know much about, but I'm sure they're based on a ton of data and, bigger and bigger computational models, right? That you can now, it's getting pretty accurate, right? The way they can predict the weather, the exact minute that the rain's going to stop, how do we apply that kind of predictive intelligence to other areas of life? And I can imagine something where a large language model is suggesting some course of action, and you have a different model that's predictive, that's trained to kind of say, well, based on all the events I've seen in the past, is this suggestion likely to pan out? Yes or no? So that kind of, when you make a decision, it's like nobody knows the future with certainty, right? But you know more when you have more data at your fingertips, right? So that's where these things really shine, is by making use of an insane amount of data that no human could ever have in their brain at one time. And so I think as we go forward in the future, we should try to use them in those ways to say, hey, how can I get this language model to leverage a bunch of historical data that I know is probably out there to help me make this decision and use it that way.
Yeah, no, and I think maybe as a final topic for our discussion, I like to end usually on trust, data trust. I'll use the example of a CEO maybe that leans over, even with a bunch of dashboards from millions of dollars of investment in data, and just asks the CFO, what do you think? And that phenomena, which is a lack of data trust from a dashboard, and now just trusting the person who you trust the most and who has the most accountability, becomes the chief decision-making framework, is an interesting one with this, because clearly in decision-making, there's sometimes that it works for you, sometimes it goes against you. And so when data is not trusted, or the outcome, unfortunately, even if the data is good, is not what people expected or is subpar, even though it's funny how the world works, where you make a decision, there's no linearity within, very complex decision making that decision then results. It's that there's a lot of work after the fact. Every founder in the world knows this. The decision is a small part of the bigger success, right? And so I think that in this world of data trust, though, where you have large data and you have lots of opportunity for data integrity issues uh, to exist, how does trust play into this? How do you mitigate these trust issues? What are the things that every company that's working on data models should be thinking if they're trying to automate and then influence decision making? What should they be doing right now to build better trust in their data?
That's a great question. I think if we're talking about large language models, also in the discussion, the I think also an emerging area of technique currently, and it's just going to get more and more commonplace, is how do you um, inject external data that is not in the text from the internet, right? Some database from your company that's proprietary, only you have access to. It's not on the internet. It's not part of the large language model. It doesn't know about it out of the box. But you want it to use that data to give you some output, help you do something, maybe help you make a decision, right? It's kind of, you want it to use its kind of general intelligence from text from the internet, plus this data to do something. And so that's going to continue to become, I think, a key aspect, a key way that we use this new tool. But then it opens up this question of, well, can I use it to help me with my trust of this data, either my data or someone else's data? Can I use a large language model to kind of like not revise, but audit or kind of look for anomalies or look for patterns? And yes, like this is what computers are best for. It's just crunching through a ton of data. And if you can combine that capability with this general intelligence from the internet, where it kind of knows what makes a good pattern, what makes a bad pattern, what should be an anomaly, what should not be an anomaly. Like, if you can kind of use it, that's going to be an exciting application and really help us with the data trust. Because the problem with data trust is, like, if you were able to go look at every single data point yourself and see the complete context of every single data point, yeah, you'd be an expert and you'd be able to make decisions with confidence and with ease. Our uncomfortableness comes because we're not able to look at every single data point. And therefore, we have to ask ourselves, how much do I trust this data? But if you can be armed with this tool, magical goggles, think of it like they can like look through the whole data set and then answer my questions, we might get to a lot higher level of trust and confidence with our data. By data, I'm just spitballing here. I mean, I don't know if this is going to happen, but it seems like that would be a useful way to improve our lives and improve our trust with data using the tools available.
Thanks, Justin. This has been a great conversation. I mean, clearly it's wonderful to go through the LLM and how this influences the landscape. Again, we're so much more aware. It's amazing how OpenAI opened that floodgate of awareness through a customer-facing application. But I have really appreciated digging into some of these bigger questions and digging into the decision-making, the effects of on decision-making of these models, and some of the things we need to do technologically to button it up. It's been a great conversation. Justin, thank you for joining today.
My pleasure. Thanks for having me. It's been fun. I love talking about this stuff.
Thank you for joining us on the AI Decision Guy podcast. Don't forget to subscribe, rate, and review our show, and be sure to tune in to our future episodes as we continue to explore the ever-evolving landscape of AI and its impact on decision-making. Until next time.